Welcome, developers and security professionals, to a deep dive into JSON deserialization exploits, a critical threat in modern web applications. JSON, or JavaScript Object Notation, is a lightweight format for data interchange, widely used for transmitting data between servers and web applications. Deserialization is the process of converting this serialized data back into an object, allowing applications to interpret and use the information. However, when untrusted JSON data is deserialized without proper validation, applications become vulnerable to severe security breaches. Insecure deserialization occurs when an application fails to validate or sanitize untrusted data, allowing attackers to inject malicious code or alter application logic. Common vulnerabilities include JSON injection, where attackers manipulate data to execute malicious code by exploiting parsing mechanisms. Server-side request forgery, or SSRF, allows attackers to force the server to make requests on their behalf, potentially accessing unauthorized internal resources. Cross-site scripting, or XSS, involves injecting malicious JavaScript into JSON responses, which is then executed by unsuspecting users' browsers. One of the most severe exploitation techniques is remote code execution, or RCE, where attackers inject code to execute arbitrary commands on the server. Attackers can also achieve privilege escalation by manipulating serialized data to gain higher-level access within an application. Data manipulation involves altering serialized data to modify application data or behavior, leading to corrupted information or unintended actions. Object injection and gadget chains allow attackers to insert malicious objects into an application's class, chaining existing classes to execute code on the system. Real-world examples include a 2016 flaw in an enterprise web application that allowed arbitrary code execution and attacks on PHP forms for admin privileges. Mitigation begins with strict input validation and sanitization of data before deserialization, ensuring only legitimate data is accepted. Using secure serialization mechanisms like JSON and avoiding vulnerable methods such as binary serialization is crucial. Implementing cryptographic controls, such as encrypting serialized data with robust algorithms like EES, prevents attackers from modifying it. Restrict deserialization to known safe types. Apply the principle of least privilege and regularly update software, libraries, and frameworks. For .NET, avoid binary formatter and ensure type name handling is none in JSON.NET. In Java, override object input stream #resolve class and use libraries like serial killer. In PHP, use JSON_decode instead of unserialize and always validate input before deserialization. JSON deserialization exploits pose a significant threat, but by understanding attack vectors and implementing robust mitigation, we can protect our systems. Regular security audits, up-to-date software, and secure coding practices are essential for maintaining a strong security posture against these dangerous vulnerabilities.